Okay, so welcome back. So now what we're going to do is we're going to work on some examples. But before we go into this example here, one of the things that you want to keep in mind is that when it comes to the comparison test, the key is you have to find a series that you know diverges or converges. And so that's one of the reasons why we use the geometric series or the p-series, because we know a lot of examples of p-series that we can come up with that we can know whether they converge or diverge. Okay, and so they're useful in helping us in using the comparison test. Okay, now here's the thing, you have to use an appropriate series that is always less than or that is always greater than the series that you're trying to test. So again, it depends on what your goal is, right? Are you trying to show that it's divergent, or are you trying to show that it's convergent? And again, some of this is going to be trial and error, and some of this is just getting used to knowing, hey, which way should I go? Should I use something to try to show that it diverges or converges? But again, the more practice, you get better at it, and sometimes it becomes obvious. Okay, so in this example, we're going to start with this example, and we're going to show whether these things converge or diverge. So I'm going to show you exactly what I mean by picking the right function. Okay, now here's the thing. If we look at this, even though it looks pretty complicated, really the controlling behavior of this equation. Think in the back of my mind, if you were to have something like this, right? What if you had something like this? Think about something like that. How would that behave? Well, we know that the behavior of this thing is controlled by the leading coefficient, right? Or by the leading term, right? So again, if you think about the behavior graphs of functions, rational functions like this one, we know that for large values of n, right, this thing is going to behave very much like 1 over n cubed. There's the clue, right? Okay, so what I'm going to do is I'm going to compare this thing to the sequence n equals 1 to infinity of 1 over n cubed. Okay, now, I also know that what? This function is going to be less than or equal to this function for all n greater than or equal to 1. We know that too, just by looking at, hey, it's got an extra positive term in the denominator here. So this fraction is always going to be smaller or equal to this fraction. Okay? So that's the other thing to consider. Okay? So how do we do this one? Okay, so first of all, we know this is a convergent p-series, right? Okay, now, here's the cool thing. Since we know this, so here's our a sub n, this is our b sub n, right? So let's make this, let me do it this way. So here is our a sub n, and here is our b sub n. And so we know, in this case here, we know that a sub n is what? Less than or equal to b sub n. Oops. Of course, that's 0, right? So we know this is true for all n greater than or equal to 1. So look, the conditions are being satisfied. This is satisfied. So this nth term, this partial sum, right? So we know that the kth partial sum is less than or equal to the kth partial sum here. And since this is a convergent p-series, this converges to a number L. And since this is also positive and increasing, and is less than or equal to this, we know it's bounded from above, and it's positive and increasing sequence of partial sums, we know that this is going to be convergent by the comparison test. Okay, so let's think about this. Okay, so again, let me write this out so it's clear. So we know that 1 over n cubed plus 3n plus 1 is less than or equal to 1 over n cubed. Okay, in fact, we can even be stronger and say that it's less than, because even at 1, it's less than. So we know this is true. So for every positive integer n, that is true. So therefore we see by the comparison test, since this is a convergent p-series, and this is true for all n greater than or equal to 1, that the series converges by the comparison test. So therefore, by the comparison test, the sequence for n equals 1 to infinity of 1 over n cubed plus 3n plus 1 converges. That's it. Have a great day.